Hello students, welcome to Saurav Sir's classes. The question is, the probability density function PDF of a random variable x is given by fx is equal to 3 by 5 plus cx squared for x greater than is equal to 0 but less than equal to 1 and fx is equal to 0 otherwise. Then the value of c is. Now we know that the summation of all probabilities gives us 1. So now, since this is a continuous variable, so integration fx dx is equal to 1, where x ranges from 0 to 1. So integrating from 0 to 1, 3 by 5 cx squared is equal to 3x by 5 plus cx cubed by 3, 1 0. So this gives us 3 by 5 plus c by 3. Now the sum equals 1, or 9 plus 5c by 15 is equal to 1, or 9 plus 5c equals 15, and this is 9, and so 5c is equal to 6 and c is equal to 6 by 5. It is option D. The next question is, limit x tends to e log x minus 1 by x minus e equals. So if we place x is equal to e, we get log e base e minus 1 by e minus e. Now this is 0 by 0 form, since log e to the base e gives us 1, so 1 minus 1 is 0, and in the denominator e minus e is 0. So what we'll do is we'll use the L'Hopital's rule. So we'll differentiate the numerator and the denominator, and we'll get 1 by x by 1, that is 1 by x, where limit x tends to e. So the answer would be 1 by e, that is option B. The next question is, let x1, x2 up to x6 be independent random variables such that probability xi equals minus 1 is equal to probability xi is equal to 1 is equal to half, where I goes from 1 to up to 6. Then probability summation I is equal to 1 to 6 xi is equal to 4 is. So for xi to be equal to 4, we would need 5 ones and 1 minus 1. This would yield the sum to be plus 4. So the required probability is 6c5 into, now we need 5 plus 1s, so half to the power 5 and 1 minus 1, so half to the power 1. So this gives me 6 into 1 by 2 to the power 6, 6 by 64, that is 3 by 32. So option B. The next question is, the domain of the function fx is equal to root 2x minus 1 by x plus 3 is. Now, since this term 2x minus 1 by x plus 3 is inside the root, so this has to be positive. Now it can be positive when both the numerator and denominator are positive, or both the numerator and denominator are negative. That is, the numerator and denominator need to be of the same sign for this to exist. Now say when both are negative, so 2x minus 1 less than 0 and x plus 3 less than 0. So from here we get x less than half and x less than minus 3. But we need to choose a value which satisfies both of these conditions. So we zero in on x less than equal to minus x less than minus 3. Now when both are positive, so 2x minus 1 greater than 0 and x plus 3 greater than 0. So from here we get x greater than equal to half and x greater than minus 3. Now using both these conditions we conclude that x greater than is equal to half. So our domain is, since x less than minus 3, so from minus infinity to minus 3 union half till infinity. So this is option B.